Hello everyone. We are going to start this new series with spectroscopy. This is focused on OChem 1 in some universities, and this is focused in OChem 2 in some universities. So I'm just gonna call it as a spectroscopy. This is sometimes a transition between OChem 1 to OChem 2. So the spectroscopy is mainly like classified into three types, especially in organic chemistry around the entry level for OChem 1 and OChem 2. So the first one is infrared spectroscopy, NMR, nuclear magnetic resonance spectroscopy, and mass spectroscopy. So the IR spectroscopy is used to recognize functional groups. The NMR spectroscopy is used to deduce the structure based on the neighboring hydrogens, while the mass spec is used to know just the mass of the molecule, and it is also helpful to recognize if we have any halogens. When I say halogens, especially like chlorine or bromine, or even if we have nitrogen atoms in the structure. I will focus on each spectroscopy in each video. So today we are just going to look at infrared spectroscopy and a brief summary. If you want something in detail, please comment and I will do a detailed video on YouTube. So the first thing is about the IR graph, like how do you recognize IR graphs? So first thing, you see them inverted peaks, and the scale goes all the way from 500 to 4000, and the scale is the frequency scale, which is usually given in wave number, and the region between 500 to 1500 is considered as a fingerprint region. The fingerprint region means, it could be the solvent, something present in the environment. It can pick up anything. So that is the reason the region between 500 to 1500 alone cannot give you the functional group or whatever kind of a bond is present. So the fingerprint region, we don't consider the peaks in the fingerprint region alone. And this from 1500 to 4000 is considered as a functional group region. And depending on how the peak looks, we can just say what kind of a functional group or what kind of a bonds or stretches, we call the mass, are present in the molecule. So if you see, usually the OH peaks show up as a very broad peaks. So these are considered as broad peaks. While the CH peaks, especially carbonyl peaks like C double bond O peaks, show as a very good sharp peaks. And for IR spectrum, you have to first memorize the regions. Most of the professors let you have like a key or a graph, but these are the most important key regions. So 1615 to 1800 is the carbonyl peak, C double bond O peak. So you get a nice sharp C double bond O peak that is going to be for your aldehydes, ketones, esters, amides, carboxylic acids. So whichever has C double bond O, you see this here. And between 2100 to 2260 or 2250, you can say, you'll see SP, C triple bond C or C triple bond, and generally triple bonds show up around this region. And the ones less than 3000 are usually your CH-SP3 peaks. SP3CH shows up less than 3000, and the one greater than 3000 is your SP2CHs. So the CH stretch is usually between 2850 to 3100, but 3000 is a point where the SP3 and SP2 get separated. The OH stretch is usually broad and it's between 3200 to 3400. And if you have a terminal alkyne, it is going to show up at 3300. So the NH peaks also show up around this region. So these are like the most important ones. Hey, how can I memorize those all? It's so difficult for me. So the fingerprint region is all your single bonds. So that's why, it's very difficult to say, hey, we can just depend on this solely. So 1500 to 2000 is where you see your double bonds. 2000 to 2500 is your triple bonds. And between 2500 to 4000 are going to be your bonds bonded to hydrogen. So the hydrogen bonds are the ones that are going to show up between 2500 to 4000. 2000 to 2500 are going to be triple bonds. 1500 to 2000 double bonds, and 400 to 1500 is single bonds. So if it is difficult for you to memorize this other chart, you can just memorize this chart and it will be helpful. So how should I solve the IR problems if I am if I'm just given this? First, let us check if there is a region around 3000, and perfect. If there is something around 3000, we can say whether it is alkyl or alkenyl. Is it sp3 or sp2? CHS. So at least that you can tell by just looking at the around 3000. If it's less than 3000, it's sp3. Greater than 3000, it's sp2. And then if there is a strong broad band in the region of 3500, so if you are seeing a broad peak, like super broad, it could be either OH, COOH, or NH2. And then let's see, in order to say that if there is a C double bond O, so let's see a peak around 1700. We need to see a nice, beautiful, sharp peak anywhere between 1650 to 1800. So let's call it around 1700. If S, then there is a carbonyl peak. And if there is a peak around 1630, little bit less than 1650, if you see a peak, then there is a C double bond C. And if there is a symmetrical alkynes or alkenes, like if you have alkyne with a bromine, hydrogen, and a bromine and a hydrogen, there is a plane of symmetry, then they don't give IR absorbance because they're canceling out each other. So let's take these clues and let's try to solve a problem now. So if you look at the IR spectrum of this 2-butanol, so first we check around 3000. So if we see everything less than 3000, so there is a sp3, there is no sp2, and we see nothing around 1700. So there is no C double bond O. And we see this broad peak. You see this pretty broad. This is indicating that there is an OH peak. So this is how you recognize IR spectrum. I hope this is helpful, and I'll make next video on how to do proton NMR and carbon NMR. Thank you.